Hi, welcome to SurvEngCalc Part 7. In this video I'm going to be discussing a new procedure that I've just added to the SurvEngCalc app, and that is a closed traverse procedure. This procedure will calculate all the necessary reductions to get finalised bowditch corrected coordinates. Okay, what you're seeing here is a small closed traverse consisting of 3 stations in which the angles have been measured or observed externally. The direction of this traverse has been travelled in a clockwise fashion and is therefore known as plus CW for use in the application. We need to remember that. If the angles have been measured internally, then the traverse has been travelled in an anti-clockwise direction, and this would be known as minus CW for use in the application. And yeah, so we just need to remember that as well. I've got some pictures here. I just want to show you if I can bring them up. So let me see. Okay, yeah, okay. So basically, this is known as plus CW because all the angles have been measured externally, and we're going in a clockwise fashion. So there's that one there, and let me have a look, see if I've got another one here. Yeah. Now this one, the angles have been measured internally, so we're going in an anti-clockwise fashion. So this would be known as minus CW. So there we're coming off the reference object whole circle bearing. We're measuring internally there, but we're still measuring the angles in a clockwise fashion, but traveling in an anti-clockwise fashion. Okay, I'm going to be using this example, the one that you can see here, to show you how the procedure works. Okay, just to explain a little bit what we're looking at here is this is obviously a clockwise traverse where the angles have been measured externally. We've got the reference object whole circle bearing going this way. That's this value here. The coordinates at station 1 here are these values here. This is the opening angle coming off the reference object whole circle bearing, and this is the closing angle which closes the traverse loop here, which is this value here. And then we've obviously got the observed angles for the other 2 stations, which are 2 and 3, which are there. We've got the distances here. So yeah, this is what we'll be using. Okay, and just to explain a little bit how the app actually works. On the first run of the app, it basically works the same as an open traverse, and it will be giving you raw whole circle bearings and raw coordinates and a raw misclosure for each of the stations. So as we come along here, we're just going to treat this as an open traverse to get the raw whole circle bearings, the raw coordinates, and we'll get a raw misclosure at the end here. Okay, so that's what we do with it. We just treat it as an open traverse. But what we're interested in is mainly is the observed angles. And what happens is from the observed angles, the app will apply the angle balancing procedure to give us balanced angles. And once the app has balanced the angles, it then reruns the same procedure as per the first run. So like the open traverse, but this time we're going to be using the balanced angles. So from doing this, from using the balanced angles, we'll be getting the corrected whole circle bearings on each of the runs here. And from the whole circle bearings, we'll be getting unadjusted coordinates. And from the unadjusted coordinates, when we get to the end here, we can get the true misclosure in eastings and northings. So from the true misclosure in eastings and northings, the app will then calculate the bowditch distance corrections and will apply them to the unadjusted coordinates to give us finalised bowditch corrected coordinates. And basically that's how the app works. I mean, my opinion, this is probably one of the easiest and quickest ways, and probably one of the most accurate ways of doing a closed traverse using the bowditch correction method. Just before we go any further, before we go into the app, I just need to discuss about if we got the here we've got the whole circle bearing for to the reference object, or azimuth if you want to call it, to the reference object is externally. in some cases we might have the reference object internally within the traverse loop. So let me just, so this is a clockwise traverse where the angles are measured externally and we're going in a clockwise fashion. But as you can see here, the reference object whole circle bearing is from within the traverse loop itself. If we've got this scenario for the application, it'll always ask for a closing angle. Now, obviously, if you're going to be doing this traverse here, you're going to be measuring this angle here, this angle here, this angle here. You're not going to measure the same angle again to close, but the app will ask for a closing angle. So all you do is re-input the opening angle. So that's there. That's just something I just want to remind you of. And I think I've got another little picture here somewhere. That one as well. Okay, this is if we're measuring the internal angles. So we're going in an anti-clockwise fashion. We're starting at station 1 there, and the bearings from within the traverse loop. So the reference object bearings actually in the traverse loop itself, and we're working our way around here. Again, we wouldn't come back and measure the same angle. So we just re-input the opening angle as the closing angle. Sorry. Okay, and that's that. So now we're gonna go into the app itself, and I'll show you how it works. Okay, I'm basically going to be using this data here. I've already got it saved in the application itself, so that's one thing you can do with all my procedures. Is you can save the data and call it back up at a later date if you want to. So I'm going to call up the station data, and then I'm going to put in the first observed angle. This is the mean observed angle. Obviously, you'll be measuring several rounds of angles to get the mean of the angle. So I'm just going to put that in. 8. And we've got a distance of 3. Press that. Okay, this is the station 2. So from station 1 to station 2, this is the raw whole circle bearing and the raw coordinates, just like you would be doing an open traverse. Okay, so now we're going to go to observe data, carry on. We're doing a closed traverse and we're going in a clockwise fashion, so it's plus CW here. If I was doing an open traverse, this would actually disappear because we don't need it. Everything's done in here, and when you reach the last station, the print button appears. Then you press print, then you can get all your data, which you can then copy and send out via the device share function if you want to. We're going to go to a closed traverse there. Okay, carrying on. I'm going to put the observed distance in is 51.252. And the observed mean angle is 263, 10, and 51.8 seconds. Got that. That's again, it's just to the next station, raw data. And I'm going to put in the next station. It's going to be 58.885. And the angle is 336, 36, and 51.7. And count that. Okay, now it's just asking me to input the closing angle. So input the closing angle, which is 312 and 23.5. Okay, I'm going to count that. Okay. Now what it's going to do is it's going to tell me to press print for data, which is this button here. This has appeared now, but we're just going to go through some of the errors now. So for this traverse, the sum of the external angles, excluding the first, should have added up to this value here. But our actual observed angle total added up to this value here. So we've got an angle of misclosure of 7 seconds there. So basically, excluding the first angle, this gets divided between the rest of them, which is 3 angles there, which is the 2 stations plus the closing angle. So that gets divided between them and comes out to this value here. And because we're 7 seconds too much here, it's going to take this off off of the other angles, the observed angles. And these here are the raw misclosures for eastings and northings. So basically, where we got back onto to this station here, that's the raw misclosure. It doesn't really mean anything, to be honest. It's just there to give you a rough idea. Okay. And the legs length total is basically the total lengths of all the legs going round the traverse. So that's the length of the traverse there. So what I'm going to do now is I'm going to press print. Okay, this little square block of data here is all the data that we've input. So that's the reference object whole circle bearing there. These are the observed angles and distances here. And from the observed angles and distances, we calculated the raw whole circle bearings. And with the raw whole circle bearings, we get the raw coordinates as if we've done an open traverse there. So basically that. And this is basically the same data as what we've just been looking at on the previous page here. So that's a raw misclosure, and that's a theoretical angle total, observed angle total there. So now what the app does, it will apply the angular correction to the angles. These are the adjusted angles now, and the angle total now adds up to this value here, which is the same as what it should be adding up to on the theoretical angle total there. So that's the correction's been applied, and from that it's corrected the whole circle bearings. Okay, so that's the whole circle bearings been corrected now, and then we get the unadjusted coordinates from the whole circle bearings now. Okay, and from the last set of coordinates here, if you look here, we've got a misclosure of 0, and we've got a misclosure of minus 3 millimeters there, and which is that. This is the true misclosure now there, and we can also work out the proportional error, which is this here, which is the accuracy of the traverse. Then from this here, we can work out the app will work out the bowditch distance corrections, which will be applied to the unadjusted coordinates here to give us the final bowditch corrected coordinates, which are down here. And that is it. It's as simple as that. So you can do as many stations as you like. And all this data here, you can just copy this, use your share function to send it out. I like to upload it to Google Drive and then open it in Google Docs and then download it to my computer as a text file. If you are going to download it as a text file, it's always best to do it from Google Docs in Google Drive, because otherwise if you try to do it normally, it just ends up all over the place. So open it up in Google Docs, then download it as a text file. And okay, folks, that is it. That's a full closed traverse calculation procedure within SurvEngCalc. Thank you very much.